Hi, I'm Adam. Welcome back to Godot Game Lab. In this episode, we'll implement the UnitMover component, which is a super important part of our whole game architecture. And what this UnitMover does is it connects to the drag and drop signals which we have from the unit's drag and drop component. So you'll notice that if I move my mouse around, the tiles are not highlighted, right? But as soon as I start dragging a unit, the tile highlighter components will be enabled so I can see where the unit will be dropped. You also see that dropping a unit snaps it to the correct tile position. And in the remote scene tree, if you take a look at it, we can see a bunch of important information. So we have our unit grids, and these units will be reparented under their corresponding unit grid. And inside the unit grid dictionary, the coordinates will be updated as the units are being moved around. So for the bench, you can see that we have one unit sitting at 3, 0, which is this character right here. And if I start dragging it, it immediately deletes this from the dictionary. And I can move it back and it gets added back in. Another cool thing we can do is we can start dragging the unit, and if we try to release it or drop it where it's invalid, where there are no tiles highlighting that it's a correct position, we release it and it gets snapped back to the position where we started the dragging from. So if we, for whatever reason, mess up the dragging, the unit gets added back to its original position, and it behaves the same way for canceling. So if instead of releasing, I press right-click over a valid position, instead of dropping it there, it will be re-added to its original position. And the final cool thing we can do, besides moving the units around, is we can swap them. So swapping the units will be handled correctly. If I grab this character over, you can see that the ID is something like 31759. And if I drag this unit and move it over Björn, they will be both claiming their new positions. You can see that at the same coordinate, we have a different object ID now, which is this character. And they also swapped places inside their unit grids. So if I go to the arena unit grid now and expand the dictionary, you'll see that I have the same object ID, this 31759, under 1 and 0, which is the correct coordinate because 0, 1, 0, 1, 2, 3, 4. So I swap them around perfectly. Awesome. So let's see how we can do this. So what about the architecture for this UnitMover component? It will be a standalone component living under the root or the arena node. So it actually has two dependencies to work correctly. First of all, we need to have access to both play areas. And then we also need the unit grids connected to those play areas so we can interact with the units as they are being moved around inside the game world. So the UnitMover itself does a very basic thing, moving units and also interacting this movement with the unit grid. What does this mean? For example, we have to make sure that when we let go of the mouse or when we drop a unit, the unit will be snapped to the correct tile position, which is being hovered over, as you can see it in the GIF. Another thing it can also do is swapping around units between the different grids. So for example, if we have a waiting unit on our bench that we want to exchange with another unit inside the game area, the UnitMover will be responsible handling those swaps and removing the new unit from the bench, assigning it to the game area, and vice versa. You might see that actually this architecture part of the videos is much shorter now, and it's because we are using standalone components. So that's the big upside of it. We can sort of just develop them or implement them in isolation and just plug them inside the game. It very rarely happens that we actually need to do some high-level orchestration, as you'll see later in the first season. So let's see how we can actually make this. So I have my project open here, and the first thing we want to do is we want to create that new component, the UnitMover. So let's go inside our file system, select the components folder, right click, create a new script, and we can call it unit_mover.gd, and make sure to turn the template off as we don't need any auto-generated code. Click on create and double click to open it up in the script editor. And let's create a first iteration of this UnitMover component. So the first thing we'll do is we'll provide a custom class name called UnitMover. Then we'll have an export variable to the play areas, which will be an array of play area nodes. The reason why we need this, if you remember from the architecture, we need to have access to both play areas and their unit grids as well. So by saying that this component needs an array of play areas, we sort of tick all the boxes, because if we have access to the play areas, then we also have access to their unit grids. Because if you remember from the last episode, if we press and hold Control and click on our play area class, they do have a unit grid assigned to them from an export variable. Then we have a private method called getPlayArea for position. What it does is it takes a global position from the game world as a vector2 and returns an integer. So what do we do here? Basically what we want to do, let me hop back to 2D for a second. If we take a global position like this one, right where my mouse is at the moment, it returns 0 because the first play area we assign to the UnitMover will be this one, right? Which occupies this space, the game area. When I move my mouse over here, it will return 1, which will be the index of the bench. So basically it takes a global position, like my mouse right now, and returns whatever game area is available at that position. If I move my mouse over here, then we will return -1, indicating that neither of the play areas are available in that given position. But if we do have one, we return the index of it. So 0 in this case, because the game area will be the first, and 1 in this case, because the bench will be the second. So let's hop back to the script and see how we can implement this. Basically, we'll use this to determine where a unit was dropped when it gets dropped. So that's why I use this variable name here, dropped area index. And this will be -1 by default, saying that we don't have any play areas which are viable. Then what we do is we loop through the number of indices that are in the array. So we ask for play areas.size, which will return 2, and we loop through all the integers, the I indices, which will be 0 and 1 respectively. Then for this other variable, we store which tile coordinate is available at that position. And for this, we use the play areas get tile from global method, which we just implemented in the last episode, because we do have a global position, which is the parameter of this method. If you remember in the last episode, we actually talked a lot and visualized how the different coordinates work, how the local coordinates work for the tile map layer, how the global coordinates work, and how it's useful to provide a method which takes, for example, a global position and returns the tile coordinate which it corresponds to. And that's exactly what we do here. So this method, if we press and hold Control and click on it, returns a vector to I, which will be a tile coordinate, right? And it takes a global position. So that's exactly what we do here. Grab that coordinate from the current play area. Then we can use the other method we have there. This is tile in bounds, and we check if that global position yielded a tile coordinate, which is a valid coordinate inside that play area. And if that's the case, we actually found that index for the play area, which we have for that position, which will be I, right? And after the loop, we return this index. Basically, in our case, 3 things can happen. If we have a global position which is outside both of the play areas, we'll return this -1 because this if will never be true. If we have a global position which is inside the game area, then this I will be 0, so we return 0. And if the tile will be inside the bounds of the bench, then this I will be 1 and we return 1. That's it for this method. Then we have another one called reset unit to starting position. It takes a vector2, which is a starting position in global coordinates, and the unit, which will be a unit instance. And what we do here is pretty simple. So first of all, we get the index for that starting position where we want to reset the units to, and store the play area index in a variable called I. So we basically call the method we just created. Then we also get the corresponding tile coordinate for the same position. And for that, we use basically the same line of code we have right here, right? At line 11. We use basically the same logic in line 20. So this is why it was useful to create that API for the play area in the last episode. We use it a bunch of times already here, right? If you remember, we had a method to reset the unit after a dragging process. So we can just call unit.reset after dragging, and this will handle anything that the unit itself needs to do after a reset. So again, we can press and hold Control over this. And if we go back, you'll see what we do, right? We disable the velocity-based rotation, and set the global position back to the starting position so the unit snaps back to where it was before. Awesome. So we don't have to handle this in the UnitMover because the unit itself can handle it. But what we do need to handle is when we reset a unit back, then we need to add it back to the unit grid where we began the process from. What does this mean? Let's stop here for a second and don't just try to understand the code, try to understand the situation where this is useful, right? Inside the game's logic. So let's go back to 2D view. And actually we can run the game as well, why not? So if I run the game and start dragging my unit, this would be a valid position, right? If this was added to the unit grid. So if I start dragging my unit and decide to cancel it, two things need to happen, and one already happens. The unit gets resetted to its original position, but we also need to add it back to the unit grid, because as soon as I will start dragging a unit, it will be removed from the unit grid, right? And if I, let's say, if I drop it here, what needs to happen is the unit gets removed from this grid and gets added to the benches grid for this position. But as soon as I start dragging the unit, it will be removed. So if I cancel, it needs to be added back to the original unit grid it was before starting the dragging. Hope that makes sense. So that's exactly what we do here. We call the unit's reset after dragging method, which will handle resetting back to the position, but we also add it back to that play area's unit grid where the unit was before. And we'll also have one final method, which is called moveUnit, which does exactly what it suggests it does. So we take a unit as a parameter, a play area, and the tile coordinate, and basically we move that unit to this play area at this coordinate. And we need to do three things to make this happen. First of all, we call the play areas unit grids add unit method for the given tile and the given unit. Then we actually need to set the position for the unit, right? So what we do is we take the unit's global position, get the correct global position for the tile coordinate we want the unit to drop to, and we basically offset it by 16 by 16 pixels to make sure that the unit looks right. And instead of yapping and explaining this, we'll just delete this when we test this method, and you'll see why we need that half cell size offset. And the final thing we want to do is when we move a unit, we actually reparent that unit to this unit grid node, which it belongs to from now on, right? Because if it's on the bench, then it will be instantiated under the bench's unit grid. But when we move it to the game area, we don't just change the position and the dictionary entries, we also want to change where it belongs inside the scene tree. So we reparent it to the game area's unit grid in this case. Okay, so we've written a bunch of code and I talked a lot. So why don't we try out these methods and you'll see how they work much better, I think. So let's scroll all the way up and see how we can test these functionalities. First of all, we can test the getPlayArea for position method. And what we do is we spam the whole output console for our project. So we call the process every frame, and what we do is we call this getPlayArea for position, and we'll just grab the global mouse position from the root node. So this ... means going up one level inside the scene tree hierarchy. And this will be the arena node because the UnitMover will be just under the arena node. So we go back one level to the root node and grab the global position from that node. Let's see how this looks when we test it. So let's save the script with Ctrl S. And let's not forget that we need to go back to 2D view and actually create this component inside our arena scene because we don't have it yet. So let's click on the plus sign or press Ctrl A with the root node selected, and this will be a simple node. So let's double click on this, double click again to rename it. Let's call this UnitMover or something like that. And we just need to drag and drop the script over like we usually do. And let's not forget to actually set the play areas. So if we click on the array, we can increment the size to have 2 of those. Click on assign, select the game area first, click on assign again and select the bench next. Awesome. So we can save the scene with Ctrl S. And if we play the game now, the output should be filled with numbers. So again, if we are not inside any of the valid play areas, we'll get -1. But if I go inside that play area where the tile highlighter works as well, you can see that we get a 0. If I move away, we get a -1 again. If I go inside the bench, I get a 1. Awesome. So that works as expected because the play area indices are like this. So 0 is for the game area, and 1 is for the bench. Awesome. So this method works. We can clear our output window, make it a bit smaller, and go back to the script tab. If we know for sure that this method works, then we can get rid of this testing code as well, because we don't need it anymore. Okay, so we can test this method next, reset unit to starting position. For example, we can do something like this. Inside the ready callback, when this node is ready in the scene tree, we can call this method with a vector 2, which is arbitrary, but in this case, I picked one which is a viable coordinate inside the game area. And we also need a unit, right? So we can make the editor smaller just to make sure that we have access to the scene tree. And from the bench, we can drag one of these units to this position. So for example, I use the first one, just drag it over here, and this will insert the node path. So that's what we have for testing purposes. Now, if we save this with Control S and run the game, we should have a unit which is reset to that position. And you'll see that it's right here. And one thing we can make sure of is that when we check the remote scene tree, resetting a unit should also add it to the unit grid, right? So let's go to Arena, Game Area, and Arena Unit Grid. And this dictionary will not be empty anymore. So we do have one unit under 0 and 1, which is the correct coordinate because this is the tile which gets highlighted when I drag the mouse over the unit. It's not at the correct position, mind you, but still it's attached to that specific grid and gets added to the unit grid dictionary as well. Awesome. So this method works as intended too. And before actually moving on to testing the move unit method, let me run this again because you might ask that, okay, we use this reset, but why is it not in the correct position? And that's a valid question, right? It looks a bit weird. And the answer lies within the use case for this method. So think about this. When do we need to call this method to reset the unit to the starting position? Basically two cases. When we either drop the unit, but we drop the unit to a position which is not a valid position. So let me show you an example. So when we start dragging this unit and I drop it here, for now what happens is it stays there, but we don't want that in the game in the future. What we want to happen in this case, if I start dragging and release it here, is that it snaps back to its original position, right? And the other use case, which kind of already works, if I start dragging the unit and I right click to cancel it, then we want it to snap back as well. In both of these cases, the starting position where we start the unit moving from will be aligned correctly to the cell, right? Because when we use this move unit method, which we are yet to test, we actually take that offset into consideration to make sure that it snaps to the correct position. So whenever we perform an invalid drop or a cancel event, we know for sure that the starting position will be a correct position inside the cell with the offset already applied. So we don't really need to do any of those calculations here, which we do here, because we can be 100% sure that the starting position will be correct. However, inside the move unit method, we need to make sure that the unit snaps to the correct position when we drop it. So that's why we grab the tile coordinate from the global position and apply this offset. So let's test this, and now it will make much more sense, I hope. So let's change this call. Well, you know what, we can leave it as is. Let's another line of code here where we do basically the same thing. We grab one unit, which will be the second unit, so we don't use the first one as well. We say that this should be moved inside the first play area, which is the game area, to this coordinate, right? 3 and 0. So let's see what that does. If we save the script with Control S and run the project, you'll see that this unit is moved to the 4th column in the first row. And you see this position is correct. So when we buy a unit, for example, we want it to spawn to this position. So this is what I was talking about for the other method. So if I start dragging this and cancel it, we can be 100% sure that the unit will end up in the correct position with the correct offset applied. So that's why we don't need to worry about this for the other one. Right now, it doesn't work with invalid drops yet, but we will implement this feature. So another thing you might want to see is what this minus arena.health cell size does. So if we delete this from the code, and run the game again, you see where it ends up. So if we go back to 2D view, press Ctrl-Shift-O and open up our unit scene, what you can see is that the unit's coordinates will be based on this top left corner. So if we were to use the global position to put it here, it looks like this, because it kind of uses the middle of the cell, this point right here. So what we want to do, we know that this is 32 by 32. So what we want to do is move it to the left by 16 pixels and then move it up 16 pixels. So what we do is we subtract and we use arena.half cell size. And this will be 16 by 16 because our cells in the game are 32 by 32. So if we type this back and run the game again, the unit will appear quite nicely inside the tile. And if we take a look at our remote scene tree here, our arena unit grid should now have 2 units stored inside it. So we have the 0, 1, which is the result of our reset, this one. And if we go to the second page, we'll have a second unit at 3, 0, which will be the result of this move unit call. So far, so good. Both of these methods work correctly too. So we can be sure that all 3 of these pieces of code work correctly, so everything we did so far works nice. So we can get rid of this code for now and save the script with Ctrl S. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. So now comes the second part where we wrap up this whole functionality. We basically need to be able to handle 3 cases for all the units. When we start dragging them, we need to remove that unit from their current play area they sit in. We also need to handle canceling a drag or dropping them to an invalid position. And lastly, we also need to handle dropping the unit to a valid position to make sure that it snaps to the tile. And if we need to swap 2 units, we can swap them. So these are the things we want to make. But for that to work, we actually need to add some functionality to our unit grid first. So let's press Ctrl-Alt-O and search for unitgrid.gd. So if you remember, this is the place where we store the units currently residing in a grid in a dictionary. Again, keys are tile coordinates and values are unit instances. And for now, we have a bunch of different public methods. We can add units, we can tell if the grid is full or the tile is occupied and so on, but we cannot really remove units. We haven't implemented that in the last episode, so we can do it right here. And it's pretty straightforward to do so. What we do is we take a tile as a parameter and we try to grab that unit as a node in that tile. So if we don't have any unit, meaning that this coordinate has null stored in it, it means that there's no unit to remove, right? So if that's the case, we can return from the function immediately. But if we do have a unit stored there, we need to override this value with null. And when we do so, we can for sure tell that there was a unit, which is not there anymore. So the unit grid is changed. So we emit that signal so everybody can be notified that this unit grid has changed. Pretty straightforward stuff. We can save this script with Ctrl S. And another thing we might want to do is related to the tile highlighter. So right now, if I run the game, the tile highlighter is enabled at all times. This can be what you want. I don't really like that. What I want to do instead is to enable these tile highlighters only when I start dragging a unit. So I see where I will drop it if I drop the unit right here. I don't really want to show it at all times. If you're fine with showing it all times, then you might not want to do this actually, but I kind of want it to work like this. So the tile highlighters should be only enabled when the dragging is happening. And to do so, we need to alter our play area a bit. So let's press Ctrl-O and search for play area.gd. And right now we only have access to our unit grid inside the play area, but I also want to have access to a tile highlighter component as well. And here I noticed something from the last episode. So if we take a look at the scene tree and go back to our arena, you see that we have our play area here, our bench, and I used an export variable for the unit grid instead of using an onReady variable reference. And the reason why is that because these unit grids have different names, right, under them. So we cannot really use a node path here because they have different names. So if we want to use node paths, we will have to rename these to have the same name. So even though I said that I don't really use export variable for child nodes, in this case where we compose together hierarchies from components, it's actually fine to do so. So here I kind of want to use the same technique or the tile highlighters. So we'll add a new export variable called tile highlighter, which will be a tile highlighter component. And by making this change and saving it with Control S, if we go back to our arena scene, we need to select both play areas and assign their corresponding tile highlighter components. And we can save this again with Control S. And the reason we need to do this is because if you remember, our UnitMover class has access to play areas. So if I want to do something with tile highlighters, I don't really have direct access to it. But now, because the class expects an export variable to set with the tile highlighter, I do have access to the tile highlighters from the play areas. The current play areas unit grid is accessible to the play area class itself. And now I can do something like, just to demonstrate this, I can press Control Space and you'll see that I have the tile highlighter and I do have access to highlight layer enabled and all the code which is there. That's pretty useful because now I can actually implement the functionality I wanted, right? Only enabling the tile highlighters when a unit is being dragged. So with all the prep work done, we can finally implement those 3 cases I was talking about. Okay, so here's what we are going to do. First of all, in the ready callback, we get all the units that are available inside our scene tree from the group called units, iterate through them, and call this setup unit method, which we are yet to implement. So we don't actually really need this piece of code because if you think about it from the game logic's perspective, we start the game with 0 units, but with some money, right? And we first buy units in order to have some units and we'll spawn them in runtime from code. But now for testing purposes, it's fine to have some units lying around like we already do, like 3 of them, right? So we'll leave those units in and that's why we have this ready callback here to make sure that we call the setup unit method. Also, what this implies is that whenever we instantiate or spawn a new unit in the future, we want to call this setup unit method on it to make sure that we can listen to the drag and drop events connected to the unit. And what does this method looks like? It's pretty simple. We'll grab the unit that we want to set up when it's spawned, or in this case, when it's already inside the game. Grab the drag and drop component, which is available for all the units, and connect to 3 signals for those 3 cases I was talking about. When the dragging is started, we'll call our own callback method called onUnitDragStarted, and we'll pass in an extra parameter besides the ones that these signals already have, which will be the unit in each of these cases. Of course, we are yet to implement all of those methods. So if we take a look at drag started, for example, if I press and hold Control and click on it, you'll see that the drag and drop component has these signals. And 2 of these signals, the canceled and the dropped signal, has the starting position as a parameter, so we can reset the unit back if we wanted to. So what we do with these binds is that we say that, okay, besides the parameters you already have, I want to pass an extra parameter, which is the unit instance itself. So now we just have to implement all 3 of these methods. We'll also have an extra method to implement this highlighter functionality I wanted, right? So I want to make sure that the highlighters are only enabled when I start dragging a unit, and all the other times it will be disabled. To make sure that it works like it's supposed to, I have this set highlighters method, which has an enabled bool property, and we just loop through all the play areas, grab the tile highlighter component, which now we have access to, because remember, we changed this to have an extra export variable, and say that the enabled property for that specific tile highlighter should be the same as the parameter we have. So this is just an extra helper function. And now on to the sort of the meat and bone of this component, those 3 callback methods. So by now you're probably used to my convention of having these callback methods at the very bottom of the class. So let's see what we need to do when we start dragging a unit. First of all, we want the highlighters to be enabled, right? Because if I start dragging a unit, let's enable those highlighters. Then what we do is we want to check if the dragging position we're starting from is inside a valid play area. Why? So what we do is we grab the index with the method we have based on the unit's global position, so we can see if we have that unit or not stored somewhere. So if that I is greater than -1, it means that this unit is on the bench or in the game area. Why is this important? What do we want to do in this case? Well, we want to remove the unit from the unit grid, right? Because when we start dragging, we said that, okay, this unit will no longer be a part of the unit grid which it started from, because we might sell it, we might drop it to another play area. So we say that as soon as we start dragging a unit from the bench, for example, we remove it from the units on the bench. And that will be super useful because if you think about the game area in the future, for example, as soon as I start dragging a unit, it will not be counted as a trait activator, right? As part of the board. And that's exactly how I want it to work, because that's what makes it feel very interactive and responsive. So we just need to check if we're starting from a valid play area position. And if we do, we grab the tile coordinate to make sure we can remove it and grab the appropriate play area, the unit grid component, and this brand new remove unit method. Pretty straightforward, right? As soon as we start dragging, enable the highlighters and remove the unit from its current grid. What about canceling the drag? So when we cancel the drag, we have two parameters: the starting position, which comes from the drag and drop signal, and the unit which we bound to this callback method. In this case, we want to say that, okay, if the drag's been canceled, then we want to set the highlighters to false, because I don't want to see tiles highlighted when I'm not dragging a unit. And we also want to call that reset unit to starting position method. Remember, if we cancel the dragging, we want the unit to snap back to its original position and re-add it to its original unit grid. Because as soon as we start dragging it, we remove it from there, right? But if we cancel it, we want to add it back, not just change the position back, but also add the unit back. And we already have this method if I click here, and it does exactly that, right? So we add it back to its original unit grid. Awesome. So far, so good. 2 out of 3. Well, simply dropping the unit is the most complicated one out of the 3, but we can manage to make sense of it, I hope. So what happens when we drop a unit? Again, we have a starting position, we have the unit. First of all, again, we want to disable all the highlighters, because dropping a unit means that I don't want the tile highlighters to be visible anymore. Also, we need to grab a bunch of variables. We need to store the original starting position of the unit. Why? Let's stop here for a second and think about this. Why do you think we need the original position and coordinate of the unit when we drop it? Actually, we have two cases. So if you thought about either of the two, or ideally both, you're really smart. If not, then just bear with me and it will make sense in a second. We need the old position and coordinate of the unit for two reasons. One of these reasons is when we drop a unit to an invalid position. Remember, we already talked about this. So if I play the game now, drag the unit and drop it over here, this should mean that it snaps back to its original position. So that's one of the cases. And the other one is where we actually drop the unit to a position where a unit already lies, right? In this case, we want to swap the units. But in order to swap the units, we need to know the original position, the original play area, and the original coordinate for the unit where we started from. Because then the unit we dropped will take the place of the unit which was already there, and the other unit will take the old position of the unit we just dropped, right? So these are both valid cases where we need to have access to the old position and coordinate of the unit. But the more trivial one is that we also need the new position, right? And the new drop area. So old area index will be the play area's index where we started the dragging from, hence using the starting position. And the drop area index will be the one where we ended up. And to do this, we'll grab the global mouse position from the unit itself. And when we have those, we can decide if the unit was dropped to an invalid position. How do we know this? If the new drop area where we ended up equals to -1 from this method we tested earlier, it means that we dropped the unit to a place where we shouldn't. And if that's the case, we only want to do one thing: reset the unit to the starting position. This is why we made this functionality its own method, because we use it right here but we also use it when the unit drag is cancelled. So to avoid repeating ourselves, we use a method which will be the same, because dropping to an invalid position is basically the same as cancelling the unit dragging. And if we do the reset, then we can return from this method because we no longer need to look for swaps or anything like that. But what about when it's not -1, when we drop it to a valid position? Then we can grab a bunch of references. We'll grab the play area for the old position, and we'll grab the play area for the new position where the unit ended up. And we do the same for the tile coordinates. So we have the tile coordinate for the old position inside the old play area, and we have the tile position or coordinate for the area where we end up dropping the unit. With those 4 variables, we need to decide if we have to swap units or not. Swapping units basically means that inside the new area's unit grid, the tile where we want to drop our unit is already occupied, right? So this if basically decides if we need to swap. And if we do, we need to make sure that we do things in the correct order. Before we can move the dragging unit to this position, it makes sense to first remove the old unit from there, right? And move it to its new place. So we'll grab a reference to the old unit which occupies the tile where we want to drop our unit from the new area's unit grid and the units dictionary with the same tile coordinate. And when we have the old unit, the reference to it, we can remove it from the unit grid where it currently lies and call the move unit method, which will add this unit to the old area, meaning the place where we started the dragging from, and the old tile, which was the original coordinate for the unit we dropped. And this move unit method will take care of adding it to the corresponding unit grid, snapping it to its tile position, and also reparenting it to the according unit grid. So with this piece of code, what we did is we moved the old unit, which occupies the tile where we dropped the unit, to its new place. And the one final thing we need to do is to move the unit to its old place. And the reason why this is not connected to the if is what? Why isn't this under our if? Well, if you think about it, this makes a very elegant code, but you need to wrap your head around this. So it doesn't really matter whether we want to swap the unit with another one or not. What we end up doing either way is moving the unit that was dropped to its new area at the new coordinate. We do this even when the space is occupied, so we have to swap, but when we have to swap, we just get the old unit out of the way first, and then we move the unit to its new place. If it wasn't occupied in the first place, this whole block of code will be skipped, and we can just move the unit to its new destination in the first place, right? Because it wasn't occupied. So that's what I ended up doing because I think this is an elegant solution. And that's all we really need for this to work. We can save this with Control S. I hope it makes sense. This onUnitDropped function is a bit of a longer one, but hopefully it makes sense. If you break it down into different parts, as I did in the explanation, I think it's not that bad. Let's go back to 2D view. And one thing we need to do if we want to make sure that the tile highlighter really only works when we drag a unit is to go back to the arena scene and actually disable them by default, because if I click on them and go back to the inspector, they will be enabled, right? It's an export property, so we can just turn these off. Save the scene. And if we run the game, we should have our unit mover ready to go, but something is wrong. You can see that no matter how I drag the unit, it doesn't really do any of the cool new stuff we implemented. And also I don't get my highlighter when I start dragging a unit. So what happens here? Why do you think it doesn't work? Let's go back to the script tab and see how these callback methods should be called, right? If we go to the ready, what we do is we grab all the units from the units group and call this setup unit method for each and every one of them. And this is where we connect the drag and drop components signals to our callback methods. That's weird. So everything looks fine. So why don't we call these methods? The problem is a pretty silly one, but hopefully we can figure it out. So if we press Ctrl+Shift+O and open up our unit scene, you might remember that we should have a little icon when the unit is added to a group, but the icon isn't there. So the thing I forgot is to actually add the units to the units group. Go ahead and select our unit node, the root node, go to groups inside our node tab and click on the plus sign to add it to a new group. And let's call it units. Click on OK, it will be added to this units group. And you can see that we now have this group icon right here. And if we hover over it, it will say that node is in this group units. Awesome. So we can save this with Control S. And now if we run the game, we should have the functionality. So yeah, you'll see that the tile highlighter becomes enabled when I start dragging the unit. And if I drop it over here, for example, it snaps to its position, the tile highlighter gets disabled. And the cool thing is that if we go to the remote scene tree under our bench and the bench unit grid, this unit will be right here reparented to it. See that? So the reparenting thing works as well. And if we open the dictionary too, you'll see that the unit will occupy the space. Awesome. So if I start dragging this, look at the coordinates here. So if I start dragging the unit, it immediately deletes it from the dictionary, right? That's what we wanted. When we start dragging, it gets deleted. But what happens if I drag the unit over an invalid spot? You'll see it snaps back to the position and the unit gets re-added to its original position. Pretty cool, right? Canceling, meaning right-click instead of just letting go of the mouse, results in the same action. The unit snaps back, the tile highlighter goes off, and the unit is added to the same place. Now, the swapping will be kind of hard to test with all of these units looking the same. And what we'll do is we'll create a new data for another unit. So let's go to Data, Units, and we can right-click and duplicate Björn. And let's do Arthur. Let's double-click on Arthur, rename him, and change it to, I don't know, rare, 4 gold. And for the skin coordinates, let's look at this picture. So Björn is 1 and 3, and I believe Arthur is the one with the big sword. So it should be 1, 2, 3, 4, and 0, 1, 2. Okay, 4 and 2. So let's do 4 and 2 for the skin coordinates. And if we go back to the arena, we can change the stats on one of these units and it should become Arthur immediately because this is a tool script. Awesome. So save this, run the game again, so we can test swapping the units around. Let's go to the remote scene tree and let's expand everything. And I don't know, let's look at the bench coordinates. Okay, so we have everything set up. If we move Arthur right here, it will be reparented under the bench unit grid, and we have the coordinate attached to it. And we can do the same with our 2 Björns as well. So they will disappear from this nowhere spot where they were, and they will be reparented under the arena unit grid. So right now we can move them around and we can add them to the bench, and you'll see that they will take their corresponding coordinates. And let's test the swapping next. So we have this object ID right here, which is for sure for Arthur. And we can do something like this. And you will notice that they swapped around correctly. And we can also see that the object ID becomes a different one. So it will be Björn's, right? Again, we can swap them around within the bench as well. So you'll see those object IDs mix and match, and the visuals update correctly as well. So everything works with the UnitMover. Now we can freely move our units inside the game world and everything works as expected. Pretty cool, right? So I hope you like this one. This is a pretty substantial part of the whole AutoBattler experience, I think, like moving units around, canceling the dragging, swapping them around. It feels nice. It already starts to come together as a user, as a player, like this strategic mastermind dragging the units around. Like, so it's super fun. Hope you liked it, and I guess I'll see you in the next one. Bye-bye.